So we're back. Concept 2.1. Use standard algorithm for division. The standard algorithm for long division is a series of steps repeated in this order: divide, multiply, subtract, and bring down. With the standard algorithm, we solve division problems one place value at a time. So we'll take the example 75 divided by 3. So the first step, we divide, but one place value at a time. So 3 goes into 7 how many times? We can figure that out, that it's 2. 3 can go into the number 7 2 times, but we'll have some extra. So we multiply. 2 times 3 equals 6. After we multiply, we have to subtract. So we figure 2 times 3 equals 6. So we put that number 6 below the number 7, and that's 7 minus 6, which equals 1. After we do that, we now bring down the number next to that original number 7. So next to the number 7 in the number 75 is the number 5. We bring that number down. Once we do that, we just simply repeat. How many times can 3 go into 15? We can do that if we know our multiplication table, or we can also divide. So in this case, 15 divided by 3 equals 5. We put that number 5 on the top. 5 times 3 equals 15. We now subtract 15 minus 15, and we have a 0 remainder. Once we have 0 remainder, we are done. The division problem 75 divided by 3 equals 25, and we're done. Another thing we have to learn is our place values. So if we look at our decimal point in our place value, which is at the center in this table, we can now look that to the left is a ones, after that is tens, after that to the left is hundreds, and we go on thousands, 10,000s, and 100,000s. And those are whole numbers that we should already know. Something new for this are the names from the decimal point to the right. And from the right, we go into tenths, hundreds, thousands, 10,000s, 100,000s. And those are the names of the place value from the decimal point of a number to the right. So now that we know the names, we consider the division expression. 700 divided by 40. So we consider 700 divided by 40. The following will result in the same quotient as another name for division. And 700 divided by 40 would result in, if we divide 70 tens by 4 tens, divide 700s by 40 ones, divide 700 ones by 40 ones. All of these represent the same thing. How do we know that? Well, if we divide 70 tens, what does 70 tens mean? 70 times 10. 70 times 10 equals 700, which is our original number. And by 4 tens, 4 times 10 is 40, which is also our original number. Then we divide 700s. 7 times 100 equals 700. We divide that by 40 ones, which is 40 times 1, which again is 40. It's our original number. We are talking about the same numbers. Finally, it says divide 700 ones, which it means 700 times 1, by 40 ones, which again we did in the problem before this one, which is 40 times 1, again 40. It's our original number. All of these expressions mean exactly the same thing. Now, we have a tricky question. Write a division expression using the digits 1, 2, 3, 4, 5, and 6. using each digit only once. The division expression should result in the greatest quotient possible. So I can simply give you the answer. That would be 6,543 divided by 12. Now, how do we know that? How did we know that 6,543 divided by 12 would result in the greatest quotient possible? Well, there's only two options that we could possibly do with division. We can divide a big number by a smaller number, or the opposite, a smaller number with a bigger number. And in this case, if we divide a big number by a smaller number, it gives us the greatest quotient. If we had done the opposite, it would equal the smallest quotient. So we are asked to use the division expression that results in the greatest quotient possible. So what is the biggest number we can possibly do? So we start with the biggest number available from 1, 2, 3, 4, 5, and 6, which again, that's how we started, 6,000. And we go on from greatest to least, 6,000, 5 is less, 4 is less, 3, and then 12 to make that the smallest number possible. So in this case, a bigger number divided by smaller equals the greatest quotient. If we had done the opposite, it would be the smallest quotient. And we move on to an example. A machine is sorting 1,847 widgets into 23 bins. When the process is complete, each bin will have the same number of widgets ready to be packaged. Use the standard algorithm for division to find how many widgets will be left over. So we can simply write it 1,847 divided by 23, and we would have to figure that question out. Another way to see it is how many times do we have to multiply 23 to equal 1,847? So we do the long division that we had already started in the introduction to this topic. So we put 23, we separate it with 1,847, and we start doing our problem solving one place value at a time. We look at the number 23. How many times can 23 fit into 1? We understand that 1 is too small, so it's 0 times. 0 times 23 is 0. So 1, we now subtract 1 minus 0, which is 1. Then we bring down the number next to 1, which is 8. And now it's 18. And we simply have to repeat. We move on to 23 and 18. How many times can 23 fit into 18? Again, it's 0. 18 is smaller than 23. So 0 times 23 equals 0. Now we subtract 18 minus 0 is again 18. And then we move the number 4, which is next to the number 18. We bring it down. Now we have 184. How many times can 23 fit into 184? So 8 times 23, we figure out, is 184 exactly. 184 minus 184 is 0. Now we could finish here, but we still have a number left over next to the 4, which is 7. We have to bring down that number 7. So it was 0, we bring down 7. Now 23, how many times can 23 fit into 7? And again, 7 is smaller, so it's 0 times. 0 times 23 is 0, so 7 minus 0 is 7. And we can just continue this, and it will always repeat and give us a remainder of 7. We can check this answer that it's 23 times 80 is 1,840. Now, 1,840 is not the original number of widgets, which is 1,847. So we take 1,847 minus 1,840, which equals 7. And that is the same answer that we had as a remainder. 7, and 7. So we know that we're done with our division problem. We move on to the next example. Gene divided 286 by 12 and got 23 with a remainder of 10. How could you check his work? So, since we just did that example, we can easily understand that the way to check division is by multiplying. So we multiply 23 by 12 and then add 10, the remainder, and check if the sum equals 286. So we do that. 23 times 12 is 276. We add 10, and does that equal 286? Yes, it does. 276 plus 10 is 286, which is our original number. Gene divided 286. So that is correct. Lenny's team wants to buy their basketball coach a commemorative plaque to remember their winning season. The plaque costs $78.76. Each of the 8 teammates agree to pay the same amount. Lenny is in charge of collecting the money for the plaque. Approximately how much should he collect from each of his teammates? So the first thing we have to do is to understand approximate, which is close to the number, but not exactly the number. So for 78.76, the approximate number would be 80. By dividing 80 divided by 8 is 10. Next, we identify the questions that involve division situations. For this one, we have to carefully analyze the phrases and the vocabulary to figure out if it's a division situation. So we look on to the first example. A theater sold $10,395 worth of tickets to a new stage production. Each ticket cost $27. How many tickets were purchased? So we have the total amount of tickets and the cost for each ticket. We can use division to figure out how many tickets were purchased. So in this case, there is a division situation. We move on to the next one. A scientist studying larvae noticed that under certain conditions, the number of larvae in a tank is doubled every 4 days. The tank started with 10 larvae. How many larvae will be in the tank after 40 days? So we look at the vocabulary in this case. And one of the keywords is doubled, which is 2 times more. In that case, we can understand that in this example, we're using multiplication. So multiplication is sometimes related to division, but it's not a division situation. So we can figure out that this is not a division situation. We will move on to the next one. A grocery store employee makes $9.50 per hour. The employee worked 3.5 hours on Monday, 3 hours on Tuesday, 3.75 hours on Wednesday, 2.25 hours on Thursday, and 4.5 hours on Friday. How much did he make that week? So we know we need to add all those hours, which adding is not a division situation, and we want to know the total amount that he made that week. So we have to multiply again. And again, multiplication is not a division situation. Our next topic. A coach had $275 to purchase new equipment for his team. He bought 4 new baseball bats for $20 each, a case of baseballs for $30, and 4 batting helmets for $25 each. How much money does he have left after making his purchase? So, how much money he has left after making his purchase, we're subtracting from the original $275 with every purchase. And again, subtraction is not division. We go on to a car rental costs $28 a day plus 2.75 per mile. If a car is rented for 4 days and driven 385 miles, what is the total cost? So again, this we need to multiply the cost per day plus the cost per mile. And in this case, multiplication again does not mean division. And finally, a delivery truck driver drives the same route every day. Every day he drives the same number of miles. The driver drove 5 days last week, a total of 1,240 miles. How many miles did he drive each day? So, in this case, we can use division because we know how many days he drove and the total amount of miles he drove for each day. We could divide to understand how many miles he drove each day. In this case, it is a division situation. Move on to our next example. Mr. Yu traveled 576 miles on 18 gallons of gas. He wants to calculate the number of miles he traveled on 1 gallon of gas. He can do this by using the standard algorithm to divide the number of miles traveled by the number of gallons of gas. So, again, we can look at the standard algorithm to divide. So we put the number 18 and then we draw the box around 576. In our first step, we have to look at number 18 to the first digit, which is 5. How many times can 18 go into 5? And again, 5 is smaller, so it's 0. 0 times 18 is 0. So 5 minus 0 is 5. And now we bring down this number 7. We move on to the next one. We look at 57 into 18, which in this case would be 3. 3 times 18 is 54. So 57 minus 54 is 3. Once we have that, we bring down the last number, which is 6. And we repeat. 2 times 18 is 36. And 36 minus 36 is 0. Once we're at 0 and there's no number left over to bring down, we can figure out that Mr. Yu's car traveled 32 miles on 1 gallon of gas. Which is the best estimate to use for this division problem? 3,218 divided by 67. So we can just easily round each number. 3,218, we can round to the nearest 100, that is 3,200, and we can round 67 to the nearest 10, and that would be 70. So the closest estimate would be 3,200 divided by 70. The easiest way to make that division problem work would be if we know our multiplication table. So from 3,200 divided by 70, it is not an easy division problem. But since we know our multiplication table, we know that 7 can easily be multiplied to reach 35. 7 times what equals 35? That would be 50. So we can round, instead of doing 3,200 divided by 70, we can round that up to 3,500 divided by 70, because 70 can easily be known to be multiplied by 50 to get 35. We know that 7 times 5 equals 35, so 3,500 divided by 70 would equal 50. That would be the best estimate, and that's why estimating is actually useful in division problems. In which of these division problems do you need to regroup the dividends hundreds to tens as the first step in using the standard algorithm? So we have 823 divided by 7, 823 divided by 71, 342 divided by 3, 342 divided by 4, and 178 divided by 12. So in the first one, we know that the number 823, the first number is 8. So if we have 8, how many times can 7 go into it? and that would be 1 when 1 left over. So we know that we can actually do that one. We don't have to regroup the divides hundreds to tens because 7 does fit into 8. And the next one, again, we have 8. In 823, the first number is 8. So how many times can 71 fit into that? And obviously, that one goes over. So for that case, we do have to regroup the divides hundreds to tens. For the next one, 342 divided by 3. The first number is 3. How many times can 3 go into 3? And that would be once. And that is simple enough. We don't have to regroup. For the next one, 342, we have the first number 3. How many times can 4 go into 3? And it goes over. So in this case, because it goes over, we do have to regroup the divides hundreds to tens. Finally, we look at 178. The first number is 1. How many times can 12 go into 1? And again, it goes over. So we have to regroup in this division problem. We move on to our next example. A chef prepared 135 desserts for a banquet. She will place the desserts on trays. Each tray holds 40 desserts. The chef divided 135 by 40 to see how many trays she will need. Her answer is 3 with a remainder of 15. What does the remainder of 15 show? So, since we've done all of these division problems, the remainder of 15 represents how many desserts would be available for a fourth tray. So we know that we're going to use 3 trays and we have a remainder of 15. So those 15 desserts would possibly fit into a fourth tray. And with that last example, we finish our concept 2.1, use the standard algorithm for division. Self-destruct in 10.
Please push the red button. Yeah, the red button. Just push it. Yeah, the red button. Push the red button. Okay, come on. The red button. Push it. You're gonna let it self-destruct? If you subscribe, you're forgiven for trying to destroy the world.